Hi, so in the first video for this week, I would like to have an overview on the exercises that you have in the slides. I will leave the exercises that you have in the lab um, up to you, and then I will discuss all of these with you on a Friday. So in the first exercise, you're asked to create three different threads in the main program um, and have them to do something for you. Let's say do 10 different steps each, 10 steps of a certain task, and then display a message after they all of them finish their jobs. So to this end, you would use join. So when main program starts the first thread and then starts the second thread and then afterwards starts the third one, they will start working eventually in a certain order, and maybe one of them will finish here. Maybe the third one will finish at this moment, and the last one will be the second thread. What we want to have is the main thread to be able to display a message when all of them finish um, their jobs at as soon as possible, actually. And the best way to do so is to use join, to let the main thread join those three threads. So every one of those threads to wait until they finish, and once all of them finish their work, the main will take over and will display a certain message like end of execution, or it could be something that has been done by those steps to be displayed there. Okay, so don't focus too much on the logic. We just want to make a technical thing here. We would just want to make sure that we are displaying the message at the end. So suppose you are displaying the end, we should have all of the messages of thread A, B, C being displayed first, no matter what the order is, and then to guarantee that the end is really displayed at the end by the main program, no matter what the order here. It should be exactly the last statement. So we should not accept any display done by any of these threads after the end. Okay? So this is the first exercise. Um, in the second exercise, you're asked to use is alive instead of join, but try to use it wisely. And a good thing here is to actually measure the execution time in both cases and to compare them. And you will notice that there is a tiny um, waste of time with the use of is alive. So even if you get the logic correctly, so just think about which operator to use when you want to check if thread 1 is alive, uh, thread 2 is alive, thread 3 is alive. So check which operator to use. So do you use an or, do you use an and? Because um, as long as any of them is still alive, you should wait, okay? So try to think about the right operator to use. So tune your logic first and make sure that the end is really displayed at the end after all of them finish their work, and then actually compare with the first approach here, okay? So to compare, actually, suggesting somewhere to use system.current_time in millisecond.current milliseconds. So I'll actually, um, uh, how this works, well, actually, this gives you a long integer that you can call start at the beginning before calling thread x.start, and um, after you finish calling join or your loops or whatever that guarantees the end of the work, you can use long and equal to the same call here. and this will give you the number of milliseconds that have been elapsed since, well, the first call since 1970, 1st of January, 12 a.m. And the second call will give you also the number of milliseconds that have been elapsed since that same date. So if you subtract those two different values, if you call and minus start, then you will get the duration or the elapsed time. Okay, but you will get it in actually in milliseconds. So you can divide it by 1000 to get the number of seconds. You can then divide it by 60 to get the number of minutes, and so on and so forth. But I think even if you keep it in milliseconds, you will get a high precision as long as you are capturing this with a long, and you will get the exact number of milliseconds that took those threads to work. By the way, this is not a technique that is useful for multi-threading, but you can actually use it in whatever program that you have. Okay, so use it in both cases, join and is alive, and check which one is more efficient. As we explained in the slides on Friday, you will see that is alive will make you waste certain amount of time. Okay, in the exercise number 3, if you have started the 3 threads in the main, how to display a message after at least one of them finishes its job. Okay, so you want to make the other case here to display a message after at least one of them has finished, and maybe to make sure that the others will quit, you can call system.exit. Okay, to kill all the other threads actually. So it's really asking to kill the current process, and hence this would finish all of the other threads. So what you will see when you run multiple times your code, you see that maybe B displaying the last step. Okay, so if you're displaying a message n times, so B will be displaying the message for the nth time. We don't care what the others will be able to do before or after that, but then the main it's guaranteed by you. It should be guaranteed by code that the main will display and. Okay, it could be that the 3 of them will be able to display the nth step before the main wakes up and display and, but this is not a big deal. Okay, but we want to eventually have the case that only one of them has finished before and then the main comes and display and, even if A and C, let's say, did not finish, or maybe C will display the nth iteration, or A, but the 2 others didn't finish, or maybe one of them at least didn't finish. Okay, so make sure after running several times that you have this logic, and especially if you call system.exit, you guarantee that the 2 other threads won't work anymore. But even if you don't call it, then the A and C will continue there after main and. Okay, so pay attention to the while condition that you use with is alive, and make sure that you are using the right logical combination. What do we have in front of us for the upcoming parts? So we have a couple of notions that we will see also with code before tackling the last theoretical part, which is about thread synchronization. So multi-threading is useful with GUI interactions. So the surprise, surprise, if you didn't know this already, please know it now. Graphic user interface lives in a special thread called the swing thread, or the UI thread. So this thread, it's working all the time, and it's kind of free painting the graphic user interface all the time on your screen with a certain frame rate per second. Okay. Why the user didn't close the window this thread remains alive, and the thread is always busy with, as I said, with repainting the components, the graphical components, the buttons, the frame itself, the window, all the panels, all the labels, and so on and so forth. So if you want to do something else that would freeze the graphical user interface, then you need to use multi-threading. So to do something else without freezing the GUI, you need to use multi-threading, or sometimes to make animations, then you also need to use multi-threading, because you want to, most basic animation would be to move a certain button, let's say from this position to that position, but to do it slowly, well, then you're increasing the X position of the button by a certain delta X. It could be a fixed delta X if you want a uniform speed. It could be a tiny delta X at the beginning, and then that increases and then decreases at the end if you want to have this um, uh, smooth start and a smooth end. So it could be something like that that goes to this position. Okay, so no matter what you want to achieve, if you want to see this button going, morphing and going smoothly from one position to another, then you need a multi-thread. Um, okay, so the examples that I will submit to the repository on GitHub, I will show them to you right away. The first one is to show the progress of reading a long file. With the bad progress, you will see that the progress bar is freezing, but then afterwards it fills in at the end at once. With the good progress example, you will see that the progress bar is filling in gradually each time you read a larger chunk of the file until it reaches the end of the file. Okay, so we'll see these examples. So this is bad progress. You will see one shot. Meanwhile, you will see it freezing. With a good progress, you will see the progress really in parallel. So by the way, yes, know it. If you need to make a simple progress bar, you already need to use multi-threading. The other example would be a simple animation that alters a certain text color or button color each 1 second. So we will use an infinite loop, and if the background color is, let's say, equal to white, we'll make it gray, and otherwise, if it's gray, then we would make it white back again. But between the two flipping of the background color, we will sleep for maybe 1 second or whatever interval of time that you want. So in this case, you will see that the button is colored. It will wait for 1 second, then it will be removed. You see a white button for 1 second, then you see it back for 1 second, and so on and so on. And you will see this button flashing in front of you. Okay. So you should be able to do this on your own, but just to make your life easier, I want to show you those examples on my own. And I will submit the code so that you can check it at home until the next session. So let's start with the bad progress example. I don't know if you are familiar with Java Swing. Maybe you learned Java FX, but it's the same spirit. So what's going here is an initialization of a certain JFrame, which is an equivalent of a window, like this window here for NetBeans. And inside that window, I have a scroll bar because I want to display a text area in which I have a panel displaying a necessarily a certain text area or a pane, yeah, an editor pane, in which a long text or a file content will go. And then I have a button called load or explore the file. And I also have a progress bar, okay, in the center of the south panel. It means to the bottom of the frame. So let me run this frame to show you at the same time the shape of the GUI. So you will see the editor pane, you will see the progress bar, and all those details. Okay, so I have an editor pane with a scroll bar, and I have a progress bar here, and I have the explore button here. What does the explore button do? So the explore button has this frame as a listener, this bad progress class as a listener. So as a listener, um, this class must implement action listener, and hence it inherits this function and it can override it. It's an action that takes in an action event. An action event is typically a mouse click, the enter of the keyboard, and so on and so forth. So it's listening to that click, and if we check e.get source, we will notice that it's equal to this button here, because the only source of events that this class is listening to is this button, if you check the code. Good. So once we click, we will open this file, the long file.txt. By the way, under NetBeans, if you want to see a certain file, then you have to go to the files window and to put your file here beside the beside your file. So I have added the long file.txt here, and I think that I have also a very long file, so maybe I have to replace it by the very long file, just in case, just to guarantee that it's working fine. Okay, good. And now, after opening it, I'm building a simple scanner, but instead of providing the system input, I'm providing the long file handle. The progress bar is set to 1024 because I think there's 1024 lines in that file. And then as long as the scanner has next, I'm reading the next line, adding it to the text pane, to the text of the pane, and then increasing the number of lines, and then setting that number of lines as the value of the progress bar. At the end, I'm closing the file, and everyone is happy. Nevertheless, in this bad progress application, if I hit the Explore button, you will see that the graphical interface is freezing, and only at the end I will have all the content plus a certain progress on the progress bar, which is really not good. So let's see it once again. So it's not resetting the progress bar, and it's freezing, and I have only one single output at the end, which is not really good. Let's check the good progress application. So I have exactly the same content, 100% the same, except that the code of the action performed function has been surrounded by the function run of a certain runnable that I pass directly to a new thread, and that new thread I'm asking it to start right away. Okay, so you see that the action performed finished line will be displayed on the screen as soon as possible to show you that once we deliver this code to the run function and we start the thread, I'm sorry, so I should have run this class. This message will be displayed as soon as possible, and nothing will be freezing. The progress bar will be continuing its work. The file load will progressively display on the screen. Nothing will be frozen, and everything will be fine. So let's see this message here in the output window below. I'm going to click on Explore. So the action performed has been already displayed. The file is still being loaded, and the progress bar has shown the progress meanwhile. So let's play it once again. So the action performed is displayed right away because the created thread is put there in the memory and has been progressing slowly while displaying the content of the file gradually and making a progress here. Okay, if you are wondering why the progress bar is not making it till the end, well, actually just because maybe I have to tune the exact number of lines with respect to the maximum value of the progress bar. Okay, but afterwards everything will be fine. Good. So what about the text flasher? So in the text flasher, let me run the code right away. So you see that I have a simple button with a certain white background that is added to the frame, and then the frame is made visible on the screen. So once it's visible, there is this tiny code here. Okay, so I have to display it on up. Let me move it somewhere to the right just to see it at the same time. So you can see here that the frame itself has a run function, okay, and in the main, I'm creating that taxi flasher. I'm asking it to start working, okay, so it is a thread. That thread goes into an infinite loop and calls alter color. Alter color change the background to gray if it was white and to white otherwise. So inside this infinite loop, I'm calling alter color, and then I'm calling thread.sleep. Of course, you still remember that we have to try catch thread.sleep because if the app was sleeping at a certain moment and then an external event comes and asks the thread to stop working, in this case, it should abide by that request and just leave the execution queue and stop sleeping. Okay. I hope that those two examples clarify um, this part for you. And then in the next video, we'll start talking about the serious matter, which is synchronization.